Hi guys, today I'd like to introduce the concept of vectors and matrices and how to use them to at least describe what happens in two dimensions. Uh, it can be generalized to many dimensions, even infinite dimension, but let's keep it simple and hopefully we'll get something out of it. So let's start with a simple idea. So it's a little bit abstract, but it will be useful to not fixate on a precise definition or exact, and because for future video I need a little bit of more abstractions. So let's start with let's say that a vector is a collection of element. Uh, let's call them f3 or 4, can be how many we want, and then we put some numbers. Okay, this is a symbol for integer. So no, actually let's keep it, I mean integer is fine, but we can use real numbers. Maybe you're familiar with the integer numbers or real numbers, but since I will use pi at some point, let's keep it real. So 1 0 minus 1 1 square 2 pi 1/3. I mean all of them are the number that you can imagine following this. These are not in order, but this is just a sample of the number that are in the real number. Okay, so what is a vector then? It's something that you can add with itself. So if you add f1 and f2, you can get another vector f, suppose n, which still is in the same set of element that you start with. So this is one thing that you can do. And the other thing that is important is that if you pick any number, let's say a, in this set of real numbers, also f times a is still another f, let's call m, is still another vector, still in the same set of vector that you started with. So I think with these two conditions, we can say that we are dealing with a vector space. So it's something that has the properties of being a vector. Now this is a little bit abstract, as you can see, because it can apply to many things. In fact, many things can be added together and stay in the same set, and many things that can be multiplied by a number will be in the same set as well. But let's be concrete and focus on an example that actually will be very useful, and it's well known. Okay, so no surprise here, we'll consider again the Cartesian axis, x and y, and we will know. And as you can see, I'm already introducing a little bit the concept of vector here, because if you think about it, this is a 0 point here. These two lines can be thought as infinite vectors, but let's not confuse ourselves. So what is a vector? A vector is a point in this space. So we define this space in 4 sections, but just because we chose this orientation of the axis, it can be any orientation, but it doesn't matter. This is just an easy one. And we pick a point, and by picking a point, we can identify this point respect to these two axes, x and y, with two, let's pick a point and make it blue, put a little bit bigger, blue point. Okay, this point can be represented with two numbers, and we know why. We've seen this with the function association in previous video. It's the same idea. So we have one point that now I have to redraw because it gets cancelled. Okay, so we have 1 point and we have two numbers. And these two numbers, which are called coordinates of the vector. We call it x1 and y1, and this is, let's call it v, this point here, v. I don't want to be pedantic, but I will do it once and then I will try to forget about it because it's a bit heavy on notation. Usually to differentiate coordinate and vector, we either use a bold symbol or a little line on top with an arrow, or maybe we can use a small line on the bottom to differentiate vectors. I think I will use the line on the bottom to differentiate vector and coordinate. Why we do that? Because a vector, in fact, it's a couple of coordinates, and usually the coordinates can be in any, in this case they are still in the same set of real numbers. So, and pictorially we can write it in column style or row style. I won't go in detail at the moment now, but let's pick the column. So we put them one on top of the other, and we say that the vector is a pair of numbers, which are the coordinates x1 and y1. And okay, but then we do a little bit more. We give a geometrical representation of the vector, which is we can draw a line that connects it to zero. Oops, a line, not a curve. It should be drawn more carefully. So let's do it this way from the top on the bottom. Yes, a line, and then we stick an arrow, a point there. Okay. Why we do that? This is because a vector also has an orientation. So as I will show you that there are some characteristics of this vector that we need to keep in mind. So the orientation, which means that it's the direction which is pointing towards to, in this case is the upper left corner, and then these two coordinates here. Okay, so let's first of all, why we need a vector in the first place. Okay, so I'm a physicist, so for me it's easy to give a simple example of why we need a vector as a coordinate in space and time, for example, for an object. So suppose you want to follow the trajectory of an object, and I will draw on the plane. I don't want to draw it in a different color, so let's pick this color here. Sorry, but and you want to draw this one. This is a trajectory, and then you want to know the position of your object. It can be a ball, it could be a project, could be an airplane, it could be a car, it could be anything you like. And then to address each of these points and understand where is the position in space or time, depending on the coordinate that you're choosing, then you associate each of these points to a vector, to a set of coordinates, and then you can describe the vectors as a nice tool to let you know how the point that you are following, the red point that you are following, suppose it starts here, is moving in space and time, for example. Okay, so this is just a practical point of view. I'm not sure if it's the way that vector were invented, and there are infinite many others usage of vector. As we will see, for example, when I will talk a little bit about simple quantum mechanics, vectors there has a totally different connotation, but the geometry and the math behind will be exactly the same. So what I want to give you is some simple ideas and concept behind the vectors and matrices that will be useful as well in other contexts. Okay, so what I want to say is, okay, so let's now, I like this picture, but let's cancel it and draw another, and I take them to think about what I'm saying next. Sure, two things about the vector. So let me we draw it here. Let's see if I can do it quickly. Okay, take a vector, and we know that this vector has 2 points, which we'll call coordinates. And what can we say about the vector? So there are two. So we said about direction and the other important thing about the vector is the length of the vector. The length is simply given by basically this. I will link it in the end of the slide. But if you remember, I mean, it's not super easy to prove it in 2 slides, so I'm not gonna do it. There are many ways to prove it, but the length of, if you remember in high school, Pythagorean theorem says that the length of a hypotenuse of a triangle is, which in this case is the length, which we'll call length. Let's call it length, and then